The Earth's water cycle begins with evaporation. The sun's energy lifts water out of the sea, forming clouds.
Hold on here. This is much too plain and boring. The real water cycle is more interesting. In fact, it's amazing. To really appreciate this natural wonder, you have to explore the many paths of water as it cycles through the planet and our lives. In urban areas, our used domestic water is also sent to used water treatment plants, which are sometimes called water reclamation plants. Why? Because this is where we reclaim the water for beneficial reuse like industrial processes and watering parks and golf courses. The basic process in a wastewater treatment plant begins with screening and grit removal. Screening removes things like some plastics, paper and other larger materials. These first processes are sometimes followed by sedimentation, where more solid particles settle to the bottom of large tanks to be collected and removed. Biological treatment normally follows screening and grit removal. This treatment process utilises naturally forming bacteria to help remove pathogens, dissolved and particulate organic material and nutrients, particularly nitrogen and phosphorus. Then there is a final disinfection step that kills the remaining pathogens in the water. So what do we do with all this water now that it's been cleaned to government standards? Is that the end of the water cycle? Well, of course it isn't. It's a cycle. And the water doesn't just fall off the edge of the earth. In many coastal communities, the water from the treatment plant is sent through a pipe and discharged into the ocean far out into the sea, where it mixes with seawater and rejoins the natural water cycle. Inland communities often discharge this water into creeks and rivers, where it flows downstream. This water mixes with the naturally flowing river water. Sometimes downstream communities use this blended river water for supplying their own needs. This water is always put back into a water treatment plant prior to use by that community. And utilities are working harder than ever to ensure that this water is safe, because we're going to need every drop. Australia's population is growing. Some say it'll reach over 33 million by 2050. With unpredictable rainfall patterns and many naturally dry areas, water shortages are a real possibility. Where this is the case, water utilities need to consider other options such as desalination or use of recycled water, in addition to conventional systems such as extracting water from more remote groundwater systems or building dams with long lengths of pipeline. In a recent trial project, Perth tested an advanced water treatment process that reclaims treated, used water and produces water that is better than normal drinking water standards. This process uses a multi-barrier approach that begins with something called ultrafiltration. Inside these filters there are tiny tubes with micropores in them that filter out bacteria, viruses and larger suspended solids. Water then goes through a process called reverse osmosis. In these filters, bundles of membranes with even smaller pores are wrapped around a central core, and pressure is used to force the water through the membranes. This filters out chemicals and compounds such as medicines that might be in the water. Finally, the water passes an intense ultraviolet light that destroys the DNA of any pathogens that might be left in the water. The result is water that is ultra pure and is often referred to as purified water. Perth has chosen to adopt this approach and put this purified water back into the ground to recharge its aquifers. This is similar to what's being done in Orange County, California, where purified water is injected into the groundwater system and later extracted for drinking water purposes.
The Global Connections Map is an interactive tool that includes stories from places in the world where water has been recycled for drinking, some for as many as 40 years.
Namibia is a drought-prone country. It's the most arid country in sub-Saharan Africa.
Within the map are videos that tell the stories of the needs and benefits of this practice for 6 different communities.
Orange County has a very vibrant economy. We have Disneyland here, that generates a tremendous amount of revenue. We also have a lot of business activity as well. And water is a key component to the economic engine that is Orange County.
In addition, there are illustrations of the technologies involved. An activated carbon filter absorbs residual micropollutants. The compounds are absorbed or adhered onto the porous surface of the carbon grains. There are also comments from citizens who drink the water.
The water has been recycled, and over here it's considered healthy when you drink it again from the tap.
Finally, a set of frequently asked questions about water recycling are answered by experts from around the globe.
Growing population is one perspective. Climate variability is another. So from 2001 through 2009 we went through the Millennium Drought. Then we've had extreme rainfall. But we will go through drought again.
While there is not time in the survey to explore all these sites, you can see that this technology is being used across the globe and is now being put into practice in Western Australia.
Climate change has hit Western Australia, especially the southern part of Western Australia, harder and faster than almost anywhere else on the planet. Over the last 2 decades, the runoff into Perth's dams has been reduced to 1/6 of the 100-year average. This has driven a rethink of our entire water strategy.
Water is vital for life on Earth, perhaps life anywhere, and is very handy for bathing. Our modern urban experience of water is that it flows from our taps and is used or enjoyed and then goes down our drains, in and out. Of course, we should remember that our wastewater doesn't just reach a final endpoint like the ocean and then, I don't know, fall off the edge of a flat Earth into space. In reality, water stays in the system, the water cycle. Most moves around this cycle via a variety of paths. Sometimes it gets around quickly, in days, sometimes slowly, thousands of years, but it does move. And this means all the water you've ever drunk, bathed, swam or washed in is recycled. In fact, we drink the same water that dinosaurs drank millions of years ago. Our planet holds an astounding amount of water, and we naturally assume it's a near infinite resource. But most is salty. And of the fresh water, most is frozen. Fresh water that humans can actually access is the tiniest fraction of the water available. It's far from evenly distributed, and very little is drinkable without treatment. And if you're attempting to provide for a modern city that's growing and in a drought, then that supposedly infinite resource suddenly feels very finite. If we can't always rely on our rivers and dams for drinking water, what do we do to keep our cities thriving? We need a range of reliable, realistic and effective options to secure a supply that's fit for our local conditions. And thinking about it, the biggest volume of extra water nearby is the water we just used, wastewater. Let's rethink and retreat wastewater so that it isn't all wasted after all.